All right. How are you all? Good afternoon to everyone. Akshit, good afternoon. Satish, good afternoon. And we started now our live class. Who are not there? Okay, Deepal present now. Okay, good afternoon, Deepal. So only three are present and one is my side. Okay, where are remaining then? Fastly come. Anyhow, we just need to discuss today about differentiability. Okay, right. Priyanshi present and Hyper Brothers is present. So now again one person went back. Who is that? Is it Hyper Brothers is there? So again two members are went back. Good afternoon. Just close your eyes and remember here itself now I'm giving for you this clue. If you all up to the end of the video if you are there, so that may be if I find in the middle also I'll check now. So up to half an hour I will check properly. So if you are use the timing of this session, okay, it is normally 1 hour, right? So if you are watching properly, then I'm going to reduce minimum 10 to 15 minutes, okay? Right, just observe carefully. I don't want to mention, need to remember. The first important point you have to remember in the differentiability is, so when the differentiability is nothing but your differentiation, which we were already discussed in limits and derivatives in your class 11, okay? So I think you all able to find now neatly. Right, Himanshu present, yes. Shubham present, Priyanshi present, but again and moving. Okay. So how to check differentiability of a function f of x? How to check differentiability of a function f of x? So here it is, remember, previously we are thinking that is left hand limit, right hand limit for continuous. But in the differentiability, left hand derivative LHD and right hand derivative, these two should be equal. Then we can say that the function is differentiable at that function. Okay. And second one, remember this carefully here. If it is not equal, then we can say that it is not differentiable at that function. So the function is not differentiable at that point. For example, at x is equal to a, they said. Then at x is equal to a, so this left hand derivative again that is same f of a minus 0. But here it is derivative, because of that we need to write f dash of a minus 0. That is left hand derivative, and right hand derivative is nothing but f dash of a plus 0. These both are equal is happened, then we can say this as a that function is a differentiable at x is equal to a. If not, function is not differentiable at x is equal to a. Okay, anyhow, we don't want to go without prayer. So just close your eyes. So I was waited because you all need to come because of that reason. Okay. Okay, that's okay. That's okay, Kirtan. And remaining, kindly concentrate more. And remember here it is nearly we need to get as minimum 13 members. So our students are 12 members, right? So one member is ours. Today is my side, 1 or 4, I don't know. That is, they are going, I get to know in the middle of this class. But if you are silently observing and you are until the end it is possible to be there, then we are going to reduce the timing of our class. Okay, right, now just close your eyes now I'm not finding their 13 members. I need to get their 13 members. 1, 3. Okay. Right. Close your eyes. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Right. Now we will go to our topic. So here mainly in this differentiability, you have to remember when this function f of x is going to be the differentiable. So here 2 points you have to remember. The first point is if left hand derivative is equal to the right hand derivative, then we can say that the function is a differentiable at x is equal to a. If both are not equal, so means that is LHD is not equal to RHD, then we can say that it is not continuous. Not only that, remember one thing here, if left hand derivative or maybe the right hand derivative, you get as infinite. Infinite is nothing but undefined. Then no need to go for example, first left hand derivative you got as undefined. So then no need to find for right hand derivative. Directly we can say that the function is not differentiable. Okay. So now mainly you have to remember here the point number one here it is function is a function is a differentiable at x is equal to a when left hand derivative equal to right hand derivative. If not, it is not going to be differentiable. And one more point you have to remember that either that is the right hand derivative or left hand derivative. If one is infinite, then we can say that the function is undefined. Otherwise, we can say that this uh, f of x at x is equal to a not differentiable. Okay, just you need to remember that. Okay, and right now it reached to 10 and it should be like stable. Right now we'll go for anyhow. I'm getting more sweat and wet because just now I was reached home and I was done the settings also. Don't worry, just 1 minute. All right. Right, my sweat. I was good. Okay. Now let we go for the example. Before going to this, you should remember. So what left hand derivative formula and right hand derivative formula. Okay. Oh, not required. Thank you for your suggestion to give water for me. It is more sweat. Okay, no problem. Just now observe carefully. At x is equal to a, left hand derivative is equal to, we can write f dash of a minus 0, that is equal to limit h tends to 0. Here formula is different. You have to remember that what is formula. Instead of here a plus, you can write instead of a minus 0 or a plus 0, you can write only f dash of a also, no problem. Good afternoon, Shubham. Okay, Trapti, good afternoon. Right, limit h tends to 0, f of, you can write this as a minus h minus f of a upon minus h, and right hand derivative is equal to f dash of a plus 0 limit h tends to 0 f of a plus h minus f of a upon h. See here, when right hand derivative happen, you need to write here plus h, plus no need to write on that time. But here it is minus h when left hand derivative. Only that part you have to remember. Remaining normal. See, it is f of a minus h minus f of a upon minus h. F of a plus h minus f of a upon h. But you learned in your 11th standard only f of a minus h minus f of a upon h. But now here you are learning that right left hand derivative means minus h you need to write. Right hand derivative means plus h you need to write. This two you have to remember as a formula. Okay. So first left hand derivative formula is this. Right hand derivative formula is this. And you can write this as only f dash of a also, no problem it is. Okay. So that is about that. And now what we'll do is we'll go to one problem so that you can understand how we can solve. But remember here, important point number one is left hand derivative must be equal to right hand derivative, then only the function is differentiable at x is equal to a. And second one, remember, any left hand derivative or maybe the right hand derivative, any one is undefined or infinite, then we can say that the function is not differentiable. Okay, these points you have to remember. And third point is these formulas you have to remember. What is that? First left hand derivative, next one right hand derivative. Okay, so that remember carefully. So now it is 11 students, Himanshu. Still two members need to required. So that 13 students happen, then your class timing is going to be reduced. Okay. And you should be like that continuously. Now one student was reduced again. Okay. Now we go for our first one. First example, example number 9 from your textbook. That is first example. So I'll go for that. First one. Example number 9. What is function? If f of x is equal to x square e power 1 upon x minus e power minus 1 upon x, that is upon e power 1 upon x minus e power minus 1 upon x. If x is not equal to 0, 0 if x is equal to 0. This is your question, and we have to find whether it is differentiable or not. So they said it is continuous at x is equal to 0. There exists f for differentiability at x is equal to 0. So we need to find, or we have to check the differentiation for f of x at x is equal to 0. So they said at x is equal to 0, then how to solve? Just observe carefully now. At x is equal to 0. So they were given that at x is equal to 0. Right. So now what I'll do, just observe carefully. First, I'll solve for left hand derivative, then I'll go for right hand derivative. So I'll go for left hand derivative. What is your formula? You have 0 given, so that f dash of 0 plus 0, that is nothing but limit h tends to 0, f of this 0 plus 0. Sorry, it is left hand derivative, so that minus, not plus. But remember, right hand derivative means plus, left hand derivative means minus. Okay. So then f of 0 minus 0 minus f of 0 upon minus, see here it is 0 minus h and minus h. This is your formula. Wherever a is there, anyhow I'll write your formula so that it is possible to be understand clearly. Here I'll write formula. So left hand derivative is equal to limit h tends to 0 f of a minus h minus f of 0 upon minus h. This is your left hand derivative formula. Now observe, a means here it is 0. So just substitute in the a plus 0 and as it is remaining same. Okay, here also this is a. So now first here f of a minus h. A plus what is here? 0. So wherever A is there, substitute 0. So here A minus H, 0 minus H. Next, here it is f of A is there. A means here 0. That's what we written here as 0 upon minus H. So now what I need to do? So now first here f of 0 minus H. Here remember here whether it is here it is x is greater than 0, x is less than 0. Function will be this only. So now f of 0 minus h means, so that is f of minus h. Wherever x is there, I need to put now minus h. So that is equal to, I'll write this part now, x square. X square means minus h whole square, then bracket e power 1 upon minus h, because x means here minus h. So then minus h. Okay, clear this. This minus from function, another minus from formula. Okay, because x means what is here? Minus h, because of that reason. So upon e power 1 upon minus h minus e power minus of 1 upon minus h. So this is done. Next, minus f of 0. What is f of 0? You already here know that f of 0 is 0. Just substitute that 0 upon, and here it is limit also equal to limit h tends to 0 and minus h is there, write that minus h. Up to here, anyone having any doubt? So what I was substituting here, it is clearly understand. Here, this is your left hand derivative formula. So here they said at x is equal to 0, I have to check the differentiability. So wherever a is there, substitute x is equal to 0. So we substituted x is equal to 0 now. So after substituting 0, 0 minus h means what you get? Minus h. Yes, Priyanshi, you can ask your doubt first. That's what I was again explaining for you all. What is that? Okay. So now observe, Shubham. See here it is. This is the function they given. F of x is equal to this. And now at x is equal to, we need to, x is equal to 0. We need to check whether it is differentiable or not. So first I am finding left hand derivative. Left hand derivative formula is limit h tends to 0. F of a minus h minus f of a upon minus h. As it is formula, I have to write. So now this is equal to limit h tends to 0. F of a means here 0. Okay, x is equal to 0 is nothing but that is your a. So now here, because we are comparing this x is equal to 0 with x is equal to a, then a is equal to what is that? 0. So now a plus 0 substituted, and then f of a plus again 0 substituted. Now check here. 0 minus h means f of minus h. So when you take left hand derivative, you need to check which is the, see if it is less than 0, what is your function? This only. Greater than 0 also function is this. So that's the reason what we need to do is this minus h, you have to substitute in this function. I just done substituted this minus h in this. So then I got minus h whole square e power 1 upon minus h, because here x only. Here minus 1 upon x, that's what minus of 1 upon x means minus h upon, again same method substituted, minus f of 0. So f of 0 means at x is equal to 0, what is your function? 0. That's the reason f of 0 is equal to 0 upon, here formula plus minus h is there, that's what minus h. Now clear? Understood now? Only left hand side now we are solving. Then we will go for right hand. First this part up to here everyone understood. Because first one problem, if you are able to understand, everything is going to be easy. Same method only. Now, okay, that is okay, Tanish. Now I am asking that whether you all understood up to this step or not. Sir, understood. Okay. Yes. So if you are understood up to here, then next step I am going to explain now. So observe carefully now here. Here minus h whole square. minus h whole square means what you are going to get? Plus h square. So anyhow, I'll write minus h whole square is nothing but plus h square. Here limit h tends to 0. Next, in this, what I can write? E power minus 1 upon h minus minus into minus plus, so that e power 1 upon h, that is upon e power 1 upon minus h, then minus minus into minus plus, so that you are going to get let me take this quotient. Okay, correct only. So then again here e power 1 upon h, h square. I feel, see here it is not minus, it is plus, so you can change this as a plus. So now what we'll write? Up minus minus 0 means no need to write that 0 upon minus h is there, right? As it is minus h. Then h square get cancelled. See this step again I am explaining. Don't worry. See here what I was done. Minus h square means what we'll write? H square. Next one. E power 1 upon minus h, as it is we written. Minus symbol, then as it is minus symbol. Then minus into minus plus e power 1 upon h written. Then after that, here check again e power minus 1 upon h. Then plus symbol is there, as it is plus symbol. Then e power minus into minus plus 1 upon h. Till that, any doubt now? After repetition, up to here, any doubt? Because how much time it happened also no problem. One problem, if you are able to understand, all problems are easy for you all. Trapti, now you are understood what I said up to here. Firstly tell. So here minus 0 is there, because of that reason we are not considering that if you are anything subtracted with the 0, we get same answer. That's what we written as same. Priyanshi, up to here any doubt? No doubt. Okay. Now can I move forward? Fastly tell, I'm checking your replies. So according to your reply, I have to. No doubt, sir. Okay. See, okay, I understood, Trapti. You came a little lately because of that reason. No problem. Once I'll explain this, after that again I'll repeat so that everyone can listen this revision part of this. Then you can understand clearly. Okay, let me go for this. So this is equal to limit h tends to 0. Now, what I will do in this place, observe carefully, only minus 1 left. So that minus h. Now, in both I'll common e power 1 upon h. So when I common e power 1 upon h, what is going to be happens? So e power 1 upon h I will common. When I common e power 1 upon h, this becomes as e power minus 2 upon h minus. So how, sir, this is minus 2 upon h k means, so here you know that e power 1 upon h, when you common, here e power 1 upon h is not there, so but upon e power 1 upon h you have to write. Simply what I will say for you, it is e power 1 upon h common, then this becomes as e power minus 2 upon h minus e power 1 upon h removed means what you get? 1. That is upon. Then we need to write this part. In this also e power 1 upon h common. Then again you get as e power minus 2 upon h plus 1. This and this get cancelled. Then what I'll do here? So this is equal to. So now simply what we can do here, it is just substitute h is equal to 0 in this place. Then you get your answer. Okay. So now when you substitute that 0, minus 0 into e power minus 2 upon 0 minus 1 upon e power minus 2 upon 0 plus 1. Okay. So when you solve this 0 into any number, what you are going to get? 0 at last. Okay. So now listen this carefully. Any problem if you have now itself you need to ask. The first one here, this is a function they given and they said to you that at x is equal to 0, whether it is differentiable or not. Okay. So then what you need to do is first you need to go for left hand derivative. First find it, get your answer. Then right hand derivative you have to take and then again we have to solve. Now first I am taking left hand derivative. So formula of left hand derivative is limit x tends to 0 f of a minus h minus f of a upon minus h. Now a means here 0. So wherever a is there substitute 0. So f of 0 minus h minus f of a means f of 0 upon minus h. Up to here no problem I think. So after that what we need to do is limit h tends to 0 minus wherever see here it is f of 0 minus h means f of minus h. Then what is your function if it is negative of 0? That means that this is your function. Just in this wherever x is there substitute minus h. Okay. Then we are substituting here minus h. So here x square means minus h whole square. Then e power 1 upon minus h because here 1 upon x minus e power minus of 1 upon x means 1 upon minus h. Then same thing just we applied here. Then after that what is f of 0? F of 0 is nothing but already they given in your question it is 0. Just substitute that 0. Now if you are subtracted 0 from any number we get the same number. So that's what as it is this written. And now here cancel this h and this h square place. So square and h get cancelled. Simply if you are feeling this total equation solving is difficult, what you need to do is very simple. So just remove the limit. See this part everything is going to be left. So now you can remove and simply want means equal to limit h tends to 0 plus just remove this limit wherever h is there substitute 0. 0 into e power minus 1 upon 0 minus e power 1 upon 0 upon e power minus 1 upon 0 plus e power 1 upon 0. That you can write 0 into any number 0. That is your equation 1. You can go for this big calculation or you can go for this. Whichever you feel as easy, you can go for that method. Now tell to me, you are understood up to this LHD. Left hand derivative, everyone understood or not? I need this clarity for this. Say fast. Himanshu, Priyanshi said yes sir, understood. Okay, where is Trapti? Trapti understood or not? Because Trapti asked repeat sir, so I was repeated. Satish, you are understood? Yes, Himanshu is understood. Okay, what about Trapti? Deepal is yes. 2 upon h. Okay, you are asking about this minus 2 upon h. Okay, that part again you want means I'll explain. If this is don't want this full calculation, you go for this. But anyhow, you answer that 2 e power minus 2 upon h. How you got? Just observe carefully. E power minus 1 upon h minus e power 1 upon h is there. In this I said we common e power 1 upon h. When I common e power 1 upon h, observe carefully now clearly. I common here e power 1 upon h. So now is there any e power 1 upon h here? Not there. So e power minus 1 upon h upon e power 1 upon h you need to write. Then minus Here it is e power 1 upon h is there. That is already common. Then what is left? 1. So that write as 1. Now this is a power m upon a power n is equal to a power m minus n. So now here minus 1 upon h is this. So write e power minus 1 upon h minus n means what is here? 1 upon h. Write that 1 upon h. So now you get here e power minus 1 minus 2 upon h. In that way, that much big procedure is there for that. How you got as that e power minus 2 upon h. Clear now? Understood now? Any doubt in this? No doubt? Can I move forward? You all understood this how you got as e power minus 2 upon h in this first method? Okay, you are understood Trapti. Okay. Now we go for another one. So means same function. Go for right hand derivative. Left hand we got as 0. Now right hand derivative we need to go. So let me go for right hand derivative. Same only formula, but only here minus place we need to write plus. So f of a plus h minus f of a upon h. Okay, this you need to remember. Okay, so then if you remember this, can you tell to me now what I need to do with this? So this is your function f of x. Now tell to me in this h tends to 0. Directly I am writing. So f of a plus h. Here a is nothing but how much? A is how much here? A is 1 or 2 or 0 na? What is that given? Give your answer. I want to check your reply. A is what they given. They said at x is equal to 0, find the differentiability. So what is our A? 0. Okay, very good. Trapti is now active. Remaining. Shubham, you are not answered for that. Right, Priyanshi 0 given. Okay, so now A is 0. So 0 plus h minus f of 0 upon h. So now wherever x is there, I need to substitute h. So this is equal to 0 plus means f of h. Substitute here h now, what you get? H square e power 1 upon h minus e power minus 1 upon h upon e power 1 upon h plus e power minus 1 upon h. So what I was done, you all I hope understood here. Just I was substituted 1 upon h where this x, wherever x is there, I was substituted h. Okay. So after completion of this, what is next? Minus f of 0. F of 0 means how much here? 0 they given. That's what write 0 upon h. And now here limit h tends to 0. H and square get cancelled. Easy method. What we need to do? Just remove the limit. Substitute that 0. 0 into e power 1 upon 0 minus e power minus 1 upon 0. E power 1 upon 0 plus e power minus 1 upon 0. 0 into number 2. So now tell to me last equation and this equation from 1 and 2 what we can say. Whether it is differentiable at x is equal to 0 or not differentiable. So up to here everyone understood or anyone not understood, inform to me now. Previously we substituted minus h. Now we are substituting plus h. So Shubham said RHD is equal to LHD. That means what? Understood? I know. Then tell to me from 1 and 2 what is that? LHD is equal to RHD. Therefore, what I can write? Differentiable. Very good. Tanish has given good answer. So it is differentiable at x is equal to 0. Now cleared everyone? For everyone understood the concept of how to check differentiability of a given function f of x. So first what I said for you. So first left hand limit by using this formula, left hand derivative by using this formula, and second right hand derivative by using this formula. You just substitute that according to the function. If you get both are equal, then we can say it is differentiable. Not equal, not differentiable. And one more also remember, in the left hand derivative or right hand derivative, any one when you are solving, if you get answer as infinite or maybe the function is undefined, then we can say that completely it is not differentiable. Okay, that is about that. If it is cleared, one more problem we are going to discuss. I think two problems we are going to discuss, then after that I am going to leave you all. Okay, and these are very simple ones only. And function I'll write now. This is your example number 10 now. 10th example. In that, then f of x is equal to x into 1 plus 1 upon 3 sine log x square. Actually, we found this previously itself, but let me check how it is again. If then here it is 0. Wow, very nice question now. I think this question is going to be completed within 1 minute if you all helping me. So here f of x is equal to x is multiplied with 1 plus 1 upon 3 sine log x square. If x is not equal to 0 means whether it is a right hand derivative or left hand derivative, we can use this as function. And at f of 0 means then we can say that as a 0. So at x is equal to 0, we need to find at x is equal to 0, we have to test. So now first f of 0 is nothing but here 0. So that you need to solve. After completion of that, what we need to do? Now we go for left hand or right hand. You tell to me which derivative you want, left or right. According to that, I can say. Shubham, you say, I need to go for right hand or left hand. Satish, you can say otherwise. Left hand or right hand you want, which one you want? So according to that, I said within 1 minute we have to complete this. So left hand many students are asked. So okay, left hand will go. So LHD is equal to f dash of 0 minus 0 is equal to limit h tends to 0 f of. So now what is here? A minus h. A means here 0. So 0 minus h minus f of 0 upon minus h. This is our formula. Then now in the function here 0 minus h means f of minus h. So then wherever here x is there, I need to substitute minus h. So now I am going to substitute here x plus minus h into then 1 plus 1 upon 3 sine log minus h whole square. You have understood what I said? Just substitute in the x place minus h. I was substituting minus. Here minus symbol. That's what here minus. F of 0 means what is h? Now anything subtracted with 0 we get a same number. And here we forgot this limit h tends to 0. So now again write this limit h tends to 0 minus h into 1 plus 1 upon 3 sine log minus h whole square is nothing but plus h square, because minus h whole square is only this number as it is we written upon. Here minus h is there, write that minus h. Minus h get cancel. So then what is going to be left now? So that is equal to limit limit h tends to 0. Now we are writing here limit h tends to 0, 1 plus 1 upon 3 sine log h square. So now observe carefully here. Now remove this limit, substitute h is equal to 0. What you are going to get? Limit removed 1 plus 1 upon 3 sine log 0 square. Log 0 square is nothing but log 0. Log 0 square is nothing but log 0. Log 0 is nothing but undefined. So here log 0 undefined means this full is going to be undefined. So we can write at last sine of log 0 is undefined. Undefined means we are going to get as infinite because log 0 is nothing but infinite. So then sine infinite, it is mathematically they can say that sine log 0 is undefined. Therefore, function f of x is not differentiable at x is equal to 0. At x equal to 0. Clear now? You are understood what I said in this? Previously itself I said you have to remember 3 points. The first one, it is left hand derivative is equal to right hand derivative. It is happened. We can say that it is differentiable. Then second point I said any one, whether it is left hand derivative or right hand derivative, any one is undefined completely. No need to go for again right hand derivative. Those are directly we can say it is not differentiable, we can say. Clear now? Any doubt in this now? So actually it is only 1 minute problem, but we took more time to explain this. Understood this? Priyanshi, okay, you said understood. And what about remaining Shubham? Shubham, Himanshu, no doubt, sir. Okay, very good. So if you are not having any doubt, then we'll go for next. Satish, no doubt. Okay. So now we'll go for 11th one. You do as a homework. 12th one is very important because previous year they given as in the examination. This is our, anyhow I promised to you I will leave you little early. So this problem is going to be the last problem for you all. Remaining you have to do as a homework because it is very easy. Okay, right? So now I can go for our next problem, that I said 12. So 11th one, when you observe, you can understand in the textbook. So now example number 12, which was given in the previous years. F of x is equal to modulus of x minus 1 plus 2 into modulus of x minus 2 minus 3 into modulus of x minus 3. Continuous at x is equal to 1, 2, 3. Then examine its differentiability. Listen this carefully. I need to check my differentiability because it is continuous at 1, 2, 3. In these places, we need to check whether it is differentiable or not. So means at x is equal to 1 differentiable or not. At x is equal to 2 differentiable or not. At x is equal to 3 it is differentiable or not. Okay. So now first let me go for first one, that is first find always and take at x is equal to 1. Remember here, if you find 1 and that one is you got as not differentiable, then all are not going to be a differentiable. You need to write once if you are found, for example, this x is equal to 1 you found, you got at last it is not differentiable. Then what we need to do is you need to write similarly for x is equal to 2, x is equal to 3 also it is not differentiable. Okay. Understood that? So now what I'll do here, it is first at f of 1. So just in this place, substitute 1 now, wherever x is there in the list. Modulus 1 minus 1 plus 2 into modulus 1 minus 1 minus 1, 0. So that's 0 plus 2 into 1 minus 2 is nothing but modulus of minus 1 minus 3 modulus of minus 2. So in the modulus number is there, we can write it as a positive number. So now we can write 0 plus, and this 2 ones are 2 minus 2 threes are 6. So now at last 2 minus 6 is nothing but minus 4. So you got f of 1 as minus 4. So now we need to find next one. Next one here it is our left hand derivative and right hand derivative. So let me go for left hand derivative first. So limit h tends to 0 f of a minus h. Now here a is nothing but 1. So that wherever there a is there, we need to substitute as 1. So when you substitute 1, f of 1 minus h minus f of 1 upon minus h. So now what I need to do? Wherever here x is there, substitute 1 minus h. So here observe carefully. Wherever x is there, I need to substitute 1 minus h. So now I am going to substitute now in that place. Total in this place I need to substitute h minus 1 plus 2 into 1 minus h minus 2 minus 3 into x means 1 minus h minus 3. So that is, then after completion of this full, minus f of 1. Minus f of 1 is how much here? Minus 4. Write that minus 4 upon minus h limit h tends to 0. Minus 1 plus 1 get cancelled. And any other simplifications are there that we need to check now. Okay. So now this is equal to limit h tends to 0. Now here minus h modulus is nothing but plus h. Now plus 2 modulus. See 1 minus 2 is nothing but minus 1. And when you remove modulus, we can write it as what? Plus symbol, because minus we can common. If you want to write, we can write that as minus h minus 1. Next one, minus 3 modulus. So here observe 1 minus 3 is nothing but minus 2. So you can write h minus h minus 2. You can write minus h minus 2. So minus into minus plus 4 upon minus h. So still we can simplify it. Limit h tends to 0, h as it is. Then so minus common in the plus. So 2 into h, we can write as 2h plus 2 into 1, 2. Next, here also minus common, then you can make it as a plus. You are understood what I said. Minus common h plus 1 modulus. And this full become as a single term. So then minus of h plus 1 is nothing, becomes as plus h plus 1. That is what I was explained here. Okay. So now what I'll write here, it is 2 into h, 2h, 2 into 1, 2, minus 3 into h, minus 3h, minus 3 into 2, that is minus 6, then plus 4 upon minus h. So that is equal to, see here 2h plus h, 3h, 3h minus h is nothing but 0. So means these all got cancelled. Now minus 6, 4 plus 2 is nothing but 6. So 6 minus 6, 0. So now we can h. So when you get 0 upon any number, 0. So now we can write limit h tends to 0, 0. That is nothing but 0. So here at last you got as, sorry, here when you are removing this limit, Okay. This you remember this carefully. When you remove like this, if you are substituted h place as 0, then it is going to be undefined. So now we can write in this place as two things are possible in this. So one is 0 you can write, and then you can go for our RHD, then that will be some other value you are going to get, and we can say that both are not equal, then it is not continuous, we can say. So here anyhow I'll write only 0 here, limit removed, and we can write as 0. Okay, clear now? Any doubt in this place now? I don't think doubt you have now in this. So that is about your 12th one. I will stop here because I said that I will leave you all at least some minutes before. So I'm going to leave you now. So study well and just practice it once. Yes, okay. Jinisha having doubt, you can ask a doubt fastly. What is your doubt? So in this nothing is there. When you get like this 0 upon any number, we written as a 0. So then next another one you can find out, and if you get, you will get that definitely as some other number, so that it is not equal, then we can say that it is not differentiable. Okay. Okay. May God bless you all, and tomorrow we'll discuss back if anything is left. Okay. You try today and tomorrow we'll discuss. May God bless you all.